Hi gentlemen, these will be your notes for Unit 1, Day 1. If you would like to see the completed warm-up or some of the example problems in the notes, then go to the finished notes that are my written version of the notes from class today. So today, we are going to be learning about the distance and midpoint formula. I'll show you where they come from and how to use them. So first, let's talk about the coordinate plane. You guys probably remember the coordinate plane. The coordinate plane is made by the y-axis that runs vertically up and down and the x-axis that runs horizontally left and right. It's divided into 4 quadrants. You have the first quadrant, which is in the upper right-hand corner. You have the second quadrant, which is in the upper left-hand corner. And then you have the third quadrant, which is in the lower left-hand corner. And the fourth quadrant, which is in the lower right-hand corner. So if you want to plot points, like the point A, we name points with capital letters. If the point A is -2, 3, you're going to move 2 to the left and 3 up, and then you can label it with a capital A. So point A would be in quadrant 2. Point B would be 4 to the right and 1 up, and point B would be in quadrant 1. Point C is the point 5, -2, so 5 to the right and 2 down. Point C would be in quadrant 4. D is 0, 3, so 0 over and 3 up. So point D would be on the y-axis. Any point where the x-coordinate is 0 would be on the y-axis. Point E is the point -4, 0, so 4 to the left and 0 up. Point E is located on the x-axis, so any point where the y-coordinate is 0 would be on the x-axis. And then the point -2, -1, so 2 to the left and 1 down, that would be point F. Point F is located in the third quadrant. So we can use points, and then we can find the distance in between them. The distance formula, it kind of looks ugly, but it comes from a formula that you're very, very familiar with, the Pythagorean theorem. So let's plot these 2 points. So -2, 3, so that's 2 to the left, 3 up. There's point A. Point B, 4, -5, so that'd be 4 to the right and 5 down, 1, 2, 3, 4, 5. Here's point B. So if I want to find the distance between those 2 points, I can use the distance formula, which I'll show you in a second, or you can use the Pythagorean theorem. The Pythagorean theorem is used with right triangles. So I need to make a right triangle where the length between A and B is going to be the hypotenuse. So I can go straight down from A and then over to B, or I can go straight over from A and then down to B. Either way, I would have 2 congruent right triangles. So now, if you remember, the Pythagorean theorem is a squared plus b squared equals c squared. So A and B are the 2 legs, so we can call this vertical side A and the horizontal side B. And the hypotenuse is going to be C. So in order to find A and B, I need to know how far up and down that side length is and how far left and right the side is to find B. So for my vertical side of that triangle, the lowest it went was -5, and the highest it went was 3. So if I go from -5 to 3, the length of that side is going to be 8. So the vertical side length is 8. For the horizontal side, it started at -2, and it traveled over to 4. So that side length is going to be 6. So the horizontal side length of my triangle is 6. The vertical side length of my triangle is 8. So to find the hypotenuse, I can use the Pythagorean theorem. 8 squared plus 6 squared equals c squared. So 64 plus 36 equals c squared. So 100 equals c squared. And then remember to find just c, you're going to take the square root. So positive or -10 is the value for c. Since we're talking about distance, it's going to be positive. So the length of segment AB is going to be 10, or the distance between the points A and B will be 10. The distance formula is the Pythagorean theorem. So notice what we did just now is we found the distance between the 2 x-coordinates. So we took the 2 x-coordinates and subtracted them. That would be the distance between the 2 x-coordinates. And then we found the distance between the 2 y-coordinates. So y2 minus y1 would give us those distance. And we subtracted them. And then in the Pythagorean theorem, it's a squared plus b squared. So we have the x distance squared plus the y distance squared. And at the end, we took the square root. So that's our distance formula. So you doing the same problem with the distance formula, x2 minus x1 would be 4 minus -2, and then squared. And then y2 minus y1 would be -5 minus 3 squared. And you take the square root. And this would become 6 squared plus negative 8 squared, but when you square something, it'll be positive, which would be 36 plus 64, which again would give us 10. So you can either make a right triangle and use the Pythagorean theorem, or you can use the distance formula. The midpoint formula allows you to find the middle of 2 points. So if you were going to find the distance between them, it would be the point that would be directly in the middle of that line segment. So let's plot these points. 3, 7, so that'd be 3 over, and then 7 up. 1, 2, 3, 4, 5, 6, 7. So we'll call that point A. And then point B is negative 5, 2. So 1, 2, 3, 4, 5, and 2. We'll call that point B. And so I want to find the middle of those segments. Well, if you want to find the middle of two numbers, you average them. So you're going to average the x coordinates, and you're going to average the y coordinates. So to find an average, you add them together and divide by 2. So you're going to take x1 plus x2 and divide by 2. You're going to take y1 plus y2 divide by 2, and that's going to be your midpoint formula. So I'm going to take 3 plus negative 5 and divide by 2. I'm going to take 7 plus 2 divided by 2. And I get negative 2 over 2, comma, 9 over 2, which should be negative 1, 4.5. You can also leave it as 9/2 if you want to. So if I'm at negative 1, 4.5, right there, we'll call it M for midpoint. That would be the midpoint of that line segment. Another way of thinking about this is with slopes. If I wanted to know how to go from A to B, I went up 5 and I went over 8. Well, you want to do half of that, so you want to go up 2.5 and over 4, and that would also get you to the midpoint. So my slope was up 5 over 8, and so if I do half the slope, I would get to the midpoint. We did this example problem in class, so you guys can look at the finished notes if you would like to see this example worked out. But right now, you guys can find the distance in the midpoint between negative 4, negative 3, and 2, 7. Is it a right triangle? Again, we worked this problem out in class, so you can look at the example from notes, but you have two options for if something is a right triangle. One, for something to be a right triangle, it needs to work with the Pythagorean theorem. So a squared plus b squared has to equal c squared. That's option one. So you would have to find the length of each side and make sure that a squared plus b squared equals c squared. C is always the longest side. Or you can use slopes. Notice for a right triangle, two of the lines need to be perpendicular. So two of the lines need to be perpendicular. Need to be perpendicular. And for things to be perpendicular, they need to have opposite reciprocal slopes. So again, you can look at the finished notes for that completed problem. Moving objects. A Ford Focus and a Freightliner Cascadia truck leave an intersection at the same time. So we'll call this the intersection right here. The Focus heads east, so we'll call this north, east, south, west. So it's traveling east at an average speed of 60 miles per hour. So here's my Ford Focus, and it's going 60 miles per hour. The Cascadia heads south at an average speed of 45 miles per hour. So here's my Cascadia, we'll call it C, and it's traveling at 45 miles per hour. Find an expression for their distance apart, D, in miles at the end of T hours. Well, to figure out how far the Ford Focus has traveled, we need to use the distance formula. Distance is equal to rate times time. I call it the DIRT formula. So I know that his rate is 60 miles per hour, but I don't know how long he's traveled for, so we'll just call that T. For the Cascadia, again, he's traveling 45 miles per hour, but I don't know how long he's traveled for, so we're going to call that time as well, because they've traveled for the same amount of time. So now the distance of this segment is going to be 45t, and the distance of this segment is going to be 60t. I want to know how far apart they are. So I'm trying to find that distance, d, right there. Well, we can use the Pythagorean theorem. 45t squared plus 60t squared is going to equal d squared. And then if you take the square root of that, you will get the distance traveled. Something to keep in mind, that is called a binomial. 45t squared plus 60t squared is a binomial. So you can't just take the square root of 45t and the square root of 60t and add them together. That won't give you the correct answer. You can actually do 45 squared and then t squared plus 60 squared and then do t squared and add them together because they'd be like terms. Again, you can look at our finished notes from class on how we worked to the end of that problem. Also during class today, we did a distance and midpoint activity. You can download those from the class module. Here is your homework. You can submit this on Canvas. So remember, in problems 7 through 14, you're going to choose any 2 problems from those to work on. 15 through 18, choose 2. 19 through 32, choose 2, and so on and so forth. So you're choosing 2 from each of those groupings to do. You can choose any 2. We're only doing one section today, so that's why the groupings are a little bit smaller than normal. If you guys have any, you also had an exit ticket, so make sure you complete the exit ticket that's on the module. If you guys have any questions over these notes, please shoot me an email.